Sat Shri Akal students. So today's topic is what are real numbers? Well, we start from natural numbers, and then when we add zero, we get whole numbers. And then when we talk about all natural numbers, zero, and all the natural numbers with minus sign, we get integers. And then the next step is real numbers. Let's understand what are real numbers. Real numbers, students, are of two types. They are rational numbers and irrational numbers. In today's lecture, we are going to discuss both in detail. So first, we will talk about rational numbers. Students, you have seen that we have some numbers 1.5, 1.22, 1.325, and then 1.555, and it continues till infinity. Similarly, 1.1111 till infinity, or 1 can be anything. Let's say 23.232323. In the same manner, it is continuing till infinity. If we closely observe these numbers, students, these three numbers, if you see, they are not continuing after this digit. In other words, you can say that they are terminating. They are terminating decimals. Or you can say ending decimals. Ending decimals. They are not continuing. But if you observe these three numbers, students, you will find that 5 is continuing till infinity. That we don't know. God knows better. Similarly here, 1 is continuing. 1, 1, 1, 1 till infinity. In this case, one digit is not repeating, rather two digits are repeating. What are those two digits? 2, 3, 2, 3, 2, 3. So these numbers are known as repeating decimals, or in some books they call it recurring decimals. All right. Interesting thing, students, both these categories of numbers are rational numbers. Now we are going to define what is the general definition of a rational number. But before that, I want to tell you, when this is the number 1.555, I can represent it like 1.5. On the 5, I'll put bar. This bar indicates it's going to repeat. So here 1.1 bar, here it will be 23.23 bar will come on two digits. Why? Because two numbers are repeating. Now it's just about how to represent them. What is the general definition of a rational number? A rational number is a number which can be expressed in the form of P by Q. What are P and Q? P and Q are integers. And there's one more thing. We know if we divide anything by 0 till date, it's not defined. So Q should not be equal to 0. Well, this is the definition of rational numbers. Now, interesting thing, students, if this is the definition of rational numbers, the question arises whether these terminating decimals and repeating or recurring decimals can also be converted into this form. let's see. Well, if you talk about the case of terminating decimals, well, this is very simple. If it is 1.2, I can write it 12 by 10. If it is 1.325, I can write it 1.325 divided by point becomes 1, 3 digits after point, 3, 0. Well, this is very simple. But if they are repeating decimals, if they are repeating decimals or recurring decimals, how to convert them into P by Q form where Q is not equal to 0. You see, students, this is it. Is this in P by Q form? Yes, both are integers and the denominator is not equal to 0. This is done. Repeating decimals. Let's take an example of 1.333. All right. 1.333 can be written as 1.3 bar. How can we represent it in this form? So the first thing you do is you assume let x is equal to 1.333 till infinity. Now, how many digits are repeating? Only 1. So you multiply both sides by 10 of this equation. On the left side, you get 10x. On the right side, when you multiply by 10, 1 3 will come out. So it becomes 13.333 till infinity. Well, the interesting thing is, how many 3's are there after the point? Infinity. Here also, how many 3 are there after the point? 1 infinity. One student who is very intuitive in maths might say, sir, 1 is less in this case, but like that's okay. But then it's such a huge number that taking 1 out of that will not create any mess. So we normally can say that they are same after decimal. Now, if this is second equation, this is first equation. If I subtract 1 from equation 2, what I get? 10x minus x is equal to 13.333 till infinity. Very interesting. Minus 1.333 till infinity. And now this right side part is same. It cancels out. Just like if I want to subtract 20.234 minus 2.274. I'm sorry, not 234, 274. I can say this decimal part is gone. Answer is 18. Simply like that, this decimal part is gone. Answer is 12. Now 9x is equal to 12. X is equal to 12 by 9. In the coprime form, it will be 3 4s are 12, 3 3s are 9. And if you divide the students, you will again get 1.333. Thank you very much. To go more deep into maths and enjoy it more, do watch our videos on our YouTube channel, Learn CBSE. Don't forget to like and share. Thank you.